Good morning, P7. So we're going to make a wee start on our reflective symmetry, and this is lesson 1. So you've watched the two videos on YouTube, and we're going to do something very similar for our first lesson that was on one of the videos. So just rolling my page out. So rotational symmetry. Sorry. So remember, there's reflective symmetry, which you're much more used to doing. This is rotational symmetry, so we're looking at rotating shapes, and we give an order of the rotation. So how many times, whenever you rotate the shape round in a full circle, how many times does it look exactly like the way it was at the beginning? Okay. So I want you to pick 8 shapes today. And I'm going to start off with some very simple ones. I'll do the first 2 or 3. So I'm just going to split my shape or my page here up into 8. You mightn't be able to see right down to the bottom. I'm leaving the bottom one slightly bigger. Okay. So up at the top, I'm going to start off with the simplest of shapes, and that's going to be a square. And that's why we wanted to do this in our problem solving book, because it means that we have nice centimeter squares. Okay. So square, 4 sides are the same length, and 4 right angles. Now, if I was to rotate that shape, which I'm going to try and do and keep it in the screen for you. So if I rotate it, so 1, 2, 3, 4. So it has a rotation in the order of 4. So I'm just going to write into the middle of the shape 4. So that means I can rotate that square in a full circle. So rotate it right round, and 4 times it looks exactly like the way it is now. So it has a rotation of 4. Now, the next one that you could do is a rectangle. I'm not going to do this one, but I'm going to draw it out for you. So it has to look exactly the same when you rotate it. So you can see that it has 2 very long sides running horizontal and 2 shorter sides running vertical. And so when you rotate it right round, so I have to rotate right round to there for it to look exactly the same, and then, oh, it's getting caught in the wire, and right round to there. So I'm not going to tell you, but hopefully you worked out what the rotation of the rectangle was. We could go for let's go for a triangle. Okay, and I'm going to try and draw an equilateral triangle, or as close to an equilateral triangle as I can. Okay, now the rotational symmetry for an equilateral triangle is different than, say, an isosceles triangle. So let's say I draw an isosceles triangle here. 1, 2, 3, 4, 5, 6, 7, 8. So here. Actually, I didn't mean it like this, but it's actually worked out to be a right angle triangle as well, because it has a right angle. It doesn't change the rotation of it. Okay. So let's go back to this one. So if I rotate it, just try and do it so you can see it on the screen. If I rotate it, I get to there, and it looks exactly the same as it was for you. And then back again to there. Can you see that? Yeah. And then back to the start. So that has a rotation of 3. But not this one. Not that one. Okay. Now there's other shapes you can do. You could do, say, a trapezium, an octagon, or a hexagon. You could draw an irregular shape like a scalene triangle, maybe at the bottom here. You could go for a circle, although it's very difficult because it has a rotational symmetry of infinite turns, because you can do it little tiny turns, and you can have as many as you like. Okay, you maybe pick that up on the YouTube videos. So at the end of today, 8 shapes. Start off with the 4 that I have. Come up with your own. You might even do shapes like arrows. You could do an arrow, or trying to think of some other shapes, parallelograms, rhombus. I just want 8. Now I would like at the very bottom of your work today to do a wee small self-assessment, because this is new, I'm sure, to almost all of you. So remember the traffic light, red, amber, green, and colour in the green. If you were really happy with everything today, no problems. And you could write in today I learned and finish that wee phrase into a sentence. So what did you learn today? Now don't say rotational symmetry, because that's clearly what you've learned, because that's the title of your work. But tell me something about rotational symmetry that you've actually learned today. Okay.